All right, students, this is the Event Detector assignment on Classroom, Activity 312. And Mr. Stallings and I have put together this activity to just sort of let you analyze a circuit, not necessarily figure out how to make one. So what we're doing here is we have provided you this event detector. Now, the reason it's called an event detector is this chip, this 74LS74, which is a D flip-flop. This chip will give an output only when an event is detected, and we'll see that in action in just a minute. But it's important to understand the concept of a few different things here. First, remembering what our active low, preset, and clear look like. Remember, it's that circle. What a positive or negative edge trigger looks like, again indicated by the circle. So in this case, this is a positive edge trigger. And then understanding the concept of handcuffing, which Mr. Stallings had talked about previously. Handcuffing means attaching a preset or a clear to the opposite value of which they're triggered. So what does that mean? Well, this is an active low preset, meaning it needs a low signal. Low digital signals are 0 volts. But if we follow this wire back, we can see it is connected to our VCC, our high signal, our 5-volt signal. So because of that, this preset will never, ever, ever, ever toggle. It will never, ever receive a value. It will never become active and become the bully, the trump card, the what I say goes, because it is handcuffed, because it is an active low connected to a high power source. Now let's look at our clear. Something a little different's going on here. We have our active low clear, again indicated by that little circle, and it can take two paths. It can either go to ground through a switch, or, if I zoom out a little bit, it can go through this resistor up to 5 volts. Well, what happens in multisim when this switch is closed, and I'm not simulating right now, let's just think critically for a second. This switch right now is closed and it's sending ground signal, and we're getting 5-volt signal from this 5-volt source up here. But what we have to remember about electricity is something we discussed pretty early on in the semester, and that is that electricity takes the path of least resistance. Path of least resistance is very self-explanatory. Notice here, I have a 10,000 kilo ohm resistor connected to my 5-volt source. I can see that on this strand of wire right here. Because of that 10,000 kilo ohm resistor, it has high resistance. Therefore, the path of least resistance will not be this way. It will not be up and down. Notice that going this way along this wire, I have 0 resistance. I have just a switch and my ground. So the path of least resistance, this clear, whenever this switch is toggled, will always go to ground. And that's an important thing to understand when we get in the topics of path of least resistance and which signal, high or low, is more dominant. Looking back at the activity, we have this event detector and we're going to perform a few different operations. We're going to close a switch, we're going to clear the flip-flop with switch C, we're going to open the switch. We're going to see what happens as we modify a few different things here. But let's talk about what exactly is going on here. Let's call this a window sensor for a home security system. And it is armed with this switch over here. So where this says key equals space, I'm going to make it A. And then it's reset over here with this switch, so I'm going to make it R. You make yours whatever you want. If you want to use, I think P and C is what we use here. Yeah, P and C, by all means. Now, let's talk about how an alarm system works. Some of you may have an alarm system in your home, some of you may not. I don't, but I can get a general understanding that I need all my sensors shut before I arm the alarm, right? If I don't have my sensors closed, if I don't have my windows closed, my door shut, and I arm my home's alarm system, meaning it can alert police, it can alert me, it can do its job, it's going to do that almost instantaneously. So we're going to call the play button up here me arming the system. Notice here, when I have the system unarmed, or when I have a window open, excuse me, when I have a window open, meaning that someone is quote unquote breaking into my house, and I arm my alarm, it's going off. The alarm's going off, it's notifying me. Well, now that window's shut, the window's shut, but the alarm is still going off. An important thing to talk about, and we'll look at that in just a second. But that's why reading through these instructions, when it says make sure that switch P is closed, make sure you reset it with switch C, make sure you do those things. Otherwise, you're not going to see what's going on here. So back to multisim. I'm going to start the simulation. Right now, my clear is open. My reset is open, and I'm sending it an active high signal. Well, what does that mean? That means that electricity is coming down, it's going through this 10 kilo ohm resistor, and it's flowing into the clear. And remember, with D flip-flops, clear trumps whatever our signal is. So this output is 0. It's always going to be 0 because we're clearing the alarm system. Now, if I close this, notice nothing still happened here, which is fine. But let's see what happens now if I keep my reset open, if I keep my clear open, and if I break the switch, if I open the window, if I kick open the door, if I do something, if I set off the alarm. Immediately, this light turns on to show that the window's open, and this light turns on to show that the alarm is going off. But I'm a pretty quick house robber. You know, I don't want to say that I am, but I'm pretty good at what I do, so I quickly shut that window. Well, in the real world, we don't want that alarm to stop going off. If that alarm stops going off, then you're going to be out a lot of money. So the window's shut, but the alarm is still going off. Why is that? Well, it's because of this event detector and how it works. So let's look at the timing diagram of this event detector. I'm going to stop my simulation and let's switch over to Excel. So here in Excel, I've got my timing diagram with Q, D, and clock. Now, this clock isn't oscillating. If you notice, this clock is not oscillating. If you notice that it's not connected to a frequency, it's connected to either 5 volts or ground right here. Right at this junction, we can follow that in to clock. Right now, it's grounded, so my clock signal is a 0. If I play, I can see that my clock signal is a 0, and I also know that, again, back to the path of least resistance. My switch is closed here, my system is alarmed, my window is shut, it's grounded, and I have a 5.6 kilo ohm resistor coming from the VCC side of my digital signal. So right now it's being sent a high signal down this path through this resistor and up to this junction. And it's being sent a low signal through this switch and up to this junction. But remember, electricity always takes the path of least resistance, which is this path. So right now, I'm sending my clock signal a 0. So let's switch to that spreadsheet. My clock signal is a 0. I'm going to draw the border as I talk about them, and let's make it a nice thick line here. So my clock signal is a 0. Well, what is my data? Well, my data is always a 1, always. You can see that it's tied into 5 volts. It can't receive signals from anywhere else. It is always going to be 5 volts. So my data is always going to be high, always. Well, if my clock is 0, and if my data is high, what is Q? Well, just because my clock isn't oscillating doesn't change anything about how a D flip-flop operates. D flip-flops operate on the trigger of a clock. So when it goes from low to high, not what is the clock. It's when the clock goes from low to high. This is a positive edge trigger clock. Looking back at this, right now, nothing's happened. I haven't gone from low to high anywhere on my clock signal. So regardless of what data is, if Q is starting as 0, it's going to stay 0. So let's draw that border up to this point right here. All right, now, the moment I open the switch, I am no longer sending a signal of 0 to my clock. I am sending a signal of 1 to my clock. Remember, path of least resistance, but this is a broken circuit. It's an open circuit, so it can only go through this route right here, which my mouse is tracing. So my clock at this given time has just become 1. I'm going to change the line color here. Right now, my clock has just toggled. Because my clock toggled, it went from low to high because it triggered. I have to now look at what is D, so what is my output? Well, if it goes from low to high, D is high, so Q goes high. And now I'm going to leave my clock open for about 5 spaces. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I close it. My clock is now getting a signal of 0 again. Great. Clock's getting a signal of 0. But notice, Q is still on here. That's because I only triggered my clock once. I only went from low to high once. So this entire time, my Q is still high. Okay, let's toggle the clock again. Let's open that window again. My window's open. My Q is still high. And that's because nothing changed with D. D has always been connected to a high signal, and the way D flip-flops work, whenever D is high, Q is high, vice versa. So here my clock went high, and we'll carry it out for the rest of this timing diagram, and Q stayed high. That is why this is an event detector. No matter what happens, whenever that window first opens, right here, between F and G, right here, whenever that window first opens, I trigger my alarm, and it stays on forever. I can open and close that window 1,000 times, and that alarm will never stop going off. The only time I can get that alarm to shut up is when my key is my switch, excuse me, not my key, my switch is closed, my window is closed, and I reset the system. Because remember, active low, preset and clear, path of least resistance. I've closed my switch, so this electricity is now getting a negative signal, a 0 signal, if you will. So clear comes into play and says, hey, look at me. I'm important now. I'm resetting the system. And then I can unreset the system, or I can turn it back on. The system is armed, the window's shut, the alarm's off, and as soon as that window opens up, the alarm goes off. That is an event detector. That is how they operate. They look at only one time. Only one time does it take for that clock to trigger in order for the alarm to go